We're going to be looking at functions and also the inverse of those functions. Now, if we take a look at question 1, we have the function x squared minus 4x plus 5. And in part A, it asks us to sketch that graph. So on first glance, we have an x squared there. So we're going to have some sort of a parabola. Okay, so before we sketch that, we're going to try and find some features of this graph, say for example the vertex, to try and sketch this parabola. So x squared minus 4x plus 5. Now that's the same thing as writing x squared minus 4x plus 4 plus 1. Now the reason I do this is because I want to complete the square. Okay, so x squared minus 4x plus 4 can be written as x minus 2 all squared plus 1. Okay, so this is really good because it looks like some sort of parabola that we can kind of graph. Okay, so from here we know that the vertex is 2 and 1. Well, how do I know that? Well, it's a parabola. So from the basic parabola x squared, okay, it transformed, okay, minus 2 and also plus 1. So the vertex from 0, 0 is going to be 2, 1 is my new vertex. So if I have my number plane here, okay, so to sketch this parabola, well, I know the vertex is 2, 1, so let's sketch it. Okay, so it's a positive parabola that goes all the way up like this. So that was part A, we're just sketching it. Now in part B, okay, now it asks us to find the rule of the inverse of fx. Okay, so that's just a long-winded way of saying let's find the inverse of this function. Okay, so let's find the inverse function. So to do that, what I'm going to do is I'm going to literally exchange my x's and y's. Okay, so I want you to have a look at this function here. Okay, what I'm going to do is, again, I'm going to put y's into all the x's and x's into all my y's. Okay, and from here, we want to make y the subject so that we have y is equal to some sort of inverse function. Okay, so that's what we're going to do. Let's try and find the rule. So from here, again, we want to make y the subject. So I'm going to try and complete the square first of all. Okay, so 5, I'm just going to split as 4 plus 1. Okay, and we can factorize like this. Okay, we can complete this square. And if I move 1 to the other side, it's going to look like this. We want to find y, so let's square root both sides. And don't forget, when we square root, we're going to have plus and minus. We can't just ignore it for no reason. And finally, if we move the negative 2 to the other side, this is what we would get. Okay, so this is my rule, or this is my equation for my inverse function. Okay, so y is equal to 2 plus minus square root x minus 1. So I'm just going to write that up here. So that was my rule for my inverse function. Now in part C, it asks us to sketch the inverse. Okay, so we found the rule of it, but let's try and sketch it. So we already sketched the original function, correct? Now from there, how do we get my inverse function? Well, inverse is just the interchanging of my x and y values. So what I'm going to do is literally reflect it off my y is equal to x graph. Okay, so here's my y is equal to x line. And from here, let's try and reflect this function. Okay, and that'll give me my inverse function graph. So reflecting it's not too difficult. Okay, so from here, that will look like horizontal parabola like this. Okay, now that's how we sketch it. Now in part D, it asks me, is the inverse of function? So we found that this was the inverse, but we're asking if that is a function. Well, how do we know if it's a function or not? Well, we can kind of do a series of tests. So one of the tests we can do is a vertical line test. Okay, so if I put a line straight down here, okay, which is represented by the red line, if I put a line straight down here, we can see, oh, it cuts twice. Okay, so if it cuts my function twice, or my graph twice, it means it's not a function. Okay, so have a look at this description. So it says the inverse does not pass the vertical line test, as it is a one-to-many relation, and therefore it is not a function. So for it to be a function, we don't want a one-to-many relation. Okay, or in other words, the vertical line test has to work. So we drew the inverse, but is this inverse a function? No, it's not, because it's a one-to-many relation. Now in part E, it asks me to find the maximum domain so that my inverse exists. So currently, with my original graph, okay, we didn't restrict the domain. Okay, and we found that if I find the inverse of it, the vertical line test doesn't work, so the inverse doesn't exist. Now the question is asking me, Well, okay, how am I going to restrict this domain? Or I want you to find the maximum domain of my original function so that if I find the inverse of it, that is also a function. Okay, so in other words, I want my vertical line test to work once I reflect it off my y equals to x. So how do I find the maximum domain of this so that that happens? Well, if I want my vertical line test to work, okay, if we kind of go backwards, we kind of want our horizontal line test to work for my original function, correct? So in that sense, we only want a portion. Okay, so I'll show you the answer first. So the maximum domain is where either x is smaller or equal to 2 or x is greater or equal to 2. Okay, so I want you to have a think about it. So if x is, let's take a look at the first one. So if x is smaller or equal to 2, okay, so here's at the vertex. So if x is smaller or equal to 2, then in my original function, we're only going to take these values. Okay, which means if I reflect it, okay, then I'm only going to take 1/2 of my function. Okay, so if I reflect this graph, the inverse of it will be this one, which means my vertical line test will work just for this portion. Okay. Similarly, if I just take the x is greater than or equal to 2, which means in my original function it is this part up here. If I reflect that, my inverse will be this, which means that my vertical line test will work. So in other words, this function currently does not exist because, well, this inverse currently doesn't exist because it's not a function. Okay, but if we only want 1/2, which means going back to my original function, my maximum domain must be either x is smaller or equal to 2 or x is greater or equal to 2.